Okay, so we've
Crazy.
got about 3 minutes before we're going to go ahead and get started. We have our guest here, Douglas, and Dr. Langdon, our mediator. So I'm going to just flip over to the next slide. If you're here for the indoor air quality for schools and how to plan for a safer school environment, you're in the right place. I know that superintendents and school districts have had a lot on their plate this year, and we thought that this would be a fitting way to end 2020 with the Wednesdays with Wightman and provide you with some really good information from Douglas on how to maintain your indoor air quality and hopefully improve it so that we can get our students back to school and that you guys can do the work that you do well. So in the chat box, if you can find where to open that, it's usually on the menu bar. Go ahead and open that, and in the chat box, on a scale of 1 to 10, 1 being poor and 10 being the best, could you please note how your school's indoor air quality is perceived? It may not be the way it is, but how it is perceived, either by your community, your administrators, your students. We're just curious to see what kind of a reaction we get. And it would help if I had my chat box open. So we'll just wait another couple of minutes, and then we'll go ahead and get started. All right, well, let's go ahead and get started. This is Wednesdays with Wightman. I'll be your facilitator today. My name is George Kakan, and I'm the education sector leader for Wightman. Through the Association for Learning, I am a recognized educational facility planner. I'm also an architect. I've been practicing for 30 years. And in that 30 years, almost all of them were in K-12 education. And I'm also a client representative for Wightman. The town hall, we created this back in March when the pandemic started, and it was to be able to provide superintendents and school administrators a forum to be able to provide best practices so that you can become informed, ask questions, and then share those best practices back in your school districts. So we thank you for being on the call today. The presentation today will really focus on indoor air quality for schools and some things that you could do either immediately or on a long-term basis. I wanted to introduce Dr. Langdon. He'll be the moderator today. He is a part-time superintendent and a mentor at Walkerville Public Schools. And I know that Dr. Langdon, you've had your hands full this year, and we've heard a lot of stories about, you know, what's been going on and what you've been planning. But he is also an educational consultant for Wightman and helps us with our clients.
Thank you.
And I'd also like to introduce our featured speaker today, and that is Mr. Douglas Lafever. He's an application engineer, and he is a president of Upgrade Evolve. He has 30 years experience in multidisciplinary engineering, and he's going to explain what that is. But in 2011, he was recognized as a legend in energy. I really like that title. And then 15 years as a building automation programming experience, and is a certified programmer by 7 automation manufacturers. That's very important. He does really know what he's talking about. So with that, Douglas, it's all yours.
All right. Thank you very much, George. I do want to first thank George and Greg Monberg for inviting me into this forum and really for your commitment to excellence. I think that that's how we found each other in this large group of professionals. So with that, not much more on my background. I'll just let everyone know that I've worked in the aviation industry and automotive manufacturing, quality test, even down to circuit board design. But I spent the bulk of my career, about 20 years, as a building automation contractor and programmer, and expanding in that industry, creating a lot of energy retrofits for older buildings. So that's brought me into a lot of the technologies, the working technologies, if you will, of modern buildings. So if you received the original email, I switched the agenda around just a little bit. to make it flow a little bit better. So we'll first talk about indoor air quality standards. Then we'll talk a little bit about the present situation of the outdoor air quality. And then we'll talk about some of the technologies and, of course, the economic impact they have on your organization. So with that, let's start with the next slide, which is the definition of indoor air quality. Really refers to the air quality within and around buildings, structures, especially as it relates to health and comfort of building occupants. All right, just a little background here. So there's two organizations that really have the greatest influence on building construction standards for air quality for buildings. And of course, the first one is ASHRAE, the American Society of Heating and Refrigeration Engineers. And they've been around for 125 years, and they've compiled a lot of studies and empirical data over the years to incorporate for the best human comfort for buildings. That's been pretty much their focus for a long time. And they interact, of course, with a lot of governmental bodies and even some of the medical organizations we have. Within the last 35 years, they focused a little bit more on indoor air quality as far as how it affects our health, what our fresh air volumes are, what the indoor pollutants are, as well as energy codes. Those have really been their focus. The second organization that has had a large influence has been the U.S. Building Green Council. And U.S. Building Green Council has adopted many of the ASHRAE guidelines and then enhanced them or maybe made them more stringent. They've done a lot of things to improve the buildings to make them more green, to reduce indoor air pollutants. They've also constantly encouraged more fresh air in the building, more than what ASHRAE's minimum standards are. So they've been a very positive influence. Now, ASHRAE has kind of turned around and taken that as feedback, and they've increased a lot of the fresh air requirements for buildings now, especially schools, mainly because a lot of organizations like the World Health Organization, the EPA, and many other groups have weighed in and done studies and found that more fresh air means better cognitive achievement for children. So, excuse me, the ASHRAE standard right now is basically on indoor air quality is called 62.1. And it basically says keep the rooms between 65 and 75 degrees and about 30 to 55% relative humidity, okay? Now, there is, ASHRAE did a study back in the 60s called the Human Comfort Index. It's much broader than this to allow existing schools not to be, like if your school was built in 1950 or 55, it followed those standards. And so the Human Comfort Index allows it not to be exempted or anything levied against them. So they may have 20% relative humidity up to 58% or something like that. But we want to get into this closer range as much as possible. So one of the comments I want to make just in general about indoor air quality is it's of course designed around the environment that you have, around the design of the building, and of course the occupant load. And then the fresh air measurements and requirements come in at this point. And these codes have changed in the last 2 decades more than they have over the 100 years before, or 80 years before. So the overlay of mechanical systems is called a building automation system. And we've had some challenges in this industry. We've had a lot of new competition in this industry. And the reason I bring this up is because they're the icing on the cake. They're the thing that make all these systems work together in either a very smooth manner or not in a smooth manner. And spending a tremendous amount of time in mitigating issues with building automation systems, reprogramming them, redesigning them. I'll give you a comparison. In the late 80s, we had 8-bit processors. We had building automation systems that when we were installed, they could apply them to every motor. They could put a motor map in of every motor in a building and measure the runtime of how many hours that motor ran, and then they could schedule maintenance based on that. So at the time, even the operator back in the 80s could map this to a graphic and use it. Now we're at 2020, and about 10% of those products are delivering that with 32-bit processors and the most complex language and graphics that are more advanced they've ever have been. We failed to deliver on some of the basics we first started with. All right, next slide. Indoor air is typically 2 to 5 times more polluted than outdoor air. Why is this? Well, really, it comes down to there are a lot of things in the air. Go ahead, next slide. So there are a tremendous amount of things I'll describe, but indoor air pollution is a real thing. And part of the reason is that our fresh air codes are bringing in 12 to 15 cubic feet per minute of fresh air per student and per adult in a school. That allows us to recirculate air as well. Now we filter that air, and that filtration method may not handle everything. It does a very good job, but remember that we've been designing for comfort for a long, long time and not indoor air pollutants. So with that, let's see here. I've got most schools are currently running about a MERV 8 filtration, okay, to trap particles down to 3 microns. Now, indoor air pollutants that they get rid of are like dust mites, some of the volatile organic compounds like formaldehyde, chlorines, pesticides, other pollutants like mold, bacteria, plastic dust is a big one as well, but they may not capture bacteria and viruses. So a virus is about, it's really a few hundredths of a micron in size. And bacteria about 3 to 7/10 of a micron in size. We'll have a comparison slide coming up. So this slide is basically an indoor air handler that might be something that you're using in your building. And these come in many, many configurations, and they're very customizable. So depending on your application, they have to be set up, programmed, and the instrumentation used to measure and manage these systems it also has to be customized as well. All right. One of the things we've done to try to retain moisture in buildings in the wintertime is to use heat recovery technology that actually traps and retains H2O. It doesn't actually trap and retain chemicals or VOCs. These are designed actually just to get the water molecule and also trap heat that is exhausted in the airstream and then allowed to go back in and heat the air that's fresh air coming in. Same thing in the summertime, they can retain some of the cooling energy and then cool down the air coming in. These are very good systems. They do a very good job, and they allow us to retain some of the moisture in the wintertime for forced air systems, but many school organizations do not have this technology. Now, this technology is also still being perfected, I think. There's a lot of very good technology out there. This was really reintroduced to the school market in the early 2000s. And I think it's still, there's still improvements made in this technology and application, but it's a very viable technology right now. All right, so indoor air quality codes are set to provide the maximum amount of CFM per zone coming in a school building. We use another tool besides heat recovery and MERV 8 filtration, and that is CO2 detection or carbon dioxide detection. And what we do with carbon dioxide detection is we actually look at the expelled CO2 in a building and we gauge how much fresh air we need to bring in. And this works very, very well because now we're taking what was a building design at a static situation and said the maximum occupancy is this many people, therefore the fresh air damper is this open all the time. Now we're saying it doesn't matter how many people, or and also like if you're in a gymnasium and working out, your CO2 level goes up per person. So it doesn't matter how many people or what they're doing. We know the parts per million in these areas, and we can adjust up and down minute by minute the outdoor air damper and bring in more fresh air for respiration. So this is a very effective tool to reduce indoor air pollution because CO2 is what we call the key indicator of indoor air quality. All right. ASHRAE has set the acceptable IAQ all the way up to 1,200 parts per million of CO2 in schools. This is acceptable. However, most organizations, again, have weighed in. A lot of educational organizations have weighed in and said that the cognitive ability of the people in the building is much better when it's around 800 parts per million or lower. All right. Let's go to the next slide. So just some takeaways here for you if you want to get the slide set later about where things are. The greater the fresh air requirements for building, the greater the energy used to process that air. There are only recommended practices for pandemic. There are no code changes yet. And school design does not currently include humidification during winter months. That's only hospitals that do that, healthcare facilities, that type of thing. All right, next slide. So when we think about the outdoor air situation, this is typically what comes to mind: fresh air in the deep forest, very high quality air. So outdoor air is the reference as fresh air for buildings. So we kind of assume that it's not dirty. It's the cleanest air possible. And that's what we hope. And so, except for like computer rooms, data labs, and operating rooms, fresh air, outdoor air pretty much matches what we want as ideal air. There are even parts of the world in the Arctic, in the Antarctica, that the particular count is so low, you could basically, it'd be equal to an operating room. So it's very amazing. There's some things I want to talk about the outdoor environment that also affect schools that are not part of air quality. One is vitamin D. We know that vitamin D deficits are huge in America as well as many parts of the world. WHO, I think, reports 80% of the people on the planet are affected by low vitamin D. One is clothing. The second is that we are inside buildings a lot. And it's important to get outside, get sunshine. We even know optically now that our circadian rhythms are set based on sunshine and the spectrum of light and sunsets. We found out that if we eliminate blue light at sunsets, even from our television screens, that allows melatonin to build. We've also found out recently that long-term eye health is connected to both ultraviolet A and B bands. We thought B was horrible forever, but now we found out that both bring some level of nourishment to our eyes. So proper hormone production, proper vitamin D levels, these all things lead to improved cognitive ability as well. Yet we do have the Human Activity Pattern Survey. If you've not heard of this before, it's revealed to us, it was conducted around 2008 to 2011, and the EPA, Harvard University, several organizations were in on this. And what we found out was this: most Americans live 90% of their lives inside buildings. So what does that do to our cognitive ability if we have elevated CO2 and we have de-elevated vitamin D, and perhaps our circadian rhythms are not working quite right because we're not getting the sunshine that we need. So getting clean air is good for us. And of course, the younger we're exposed to potential allergens, it's been proven that the less likely we are to have asthma, multiple chemical sensitivity, and several of these conditions that young people have now. While the majority of schools are in rural areas, many are in urban. So this is doubly difficult for urban schools to figure out how to get the children outdoors in the environment that's a healthy environment. PM10, PM5, PM2.5, these are all called particulate matter. And the 10 is 10 microns down to 2.5 microns. Even ozone are hazards in our urban environment. Indoor environments protect us from these excessive amounts of pollutants. So on one side, fresh air in the deep forest is fantastic. You get out and you're near a traffic situation, you have an elevated ozone level, you have particulate matter that is not healthy for you. Now you actually are finding that the school inside is a better place to be. So now you can see why the architects, the industry are all challenged to find the healthiest place for us to be, but not to be all the time. I'm looking to see here. So let's go to the next slide. Let's talk about CO2 real quickly in the outdoor air. We talked about acceptable limits inside. This is the atmospheric CO2 measurement, basically done daily in Mauna Loa laboratories or observatory in Hawaii. And this is our map from about 1958 to 2020. And it shows us that the CO2 is rising on the planet. So we know this is one of the contributors to global warming that makes it excessive right now. And it also tells us something else that no one is talking about. This is displaced oxygen. The more CO2 we have, the less oxygen we have to breathe. So the concern is if we don't turn this trend around, it's very difficult as to bring enough fresh air in to the building because it's not out there already. All right. So this is let's see, last summer, CO2 was up to 410 parts per million, and it's still rising. The 2020 ASHRAE recommendation for this year for the pandemic is to flood buildings with as much fresh air as possible, okay? So lower your CO2 count as low as possible. So if it's possible to have 410 outside of parts per million and 410 inside, that's what they're recommending. Okay, next slide, please. I've turned my notes upside down, sorry about that. So Frank Lloyd Wright, he said, I go every day for inspiration in the day's work. Kind of makes you wonder if he didn't go out, outside a house at some point or outside a building and get some sunshine and fresh air and kind of get some inspiration. So we know it's good for us. I've got a study marked here by Joseph Allen, Director of Healthy Buildings Program at Harvard University. He published in Environmental Health Perspective his test where he proved that lower volatile organic compounds and CO2 levels in classroom and education resulted in 101% cognitive improvement in students in 30 minutes. So what he did was he took conventional CO2 spaces that may have been 1,200 parts per million or higher, and he moved students to a very low, like 800 parts per million, and he tested them in both environments. And what he got was consistently 101% improvement in cognitive ability. So you could imagine what that would do for your students if they went out in the fresh air for 15 minutes or 20 minutes and came back in, or that you made improvements in your fresh air quality in your building itself. So for rural schools, outdoor time is healthy. It's easy to implement. It's much more difficult for urban schools. They're going to have to find some of their breaks when, in the morning before particulate matter 2.5 and ozone builds up, before there's a lot of traffic. So it's very, very difficult sometimes to find that. Next slide. This is PM 2.5, what I've been referring to for a while. So in the last decade, research has basically told us that particulate matter 2.5 microns or smaller, we breathe in, that goes directly into our bloodstream. So there are studies linking increased heart attacks due to this, that it's a long-term contributor to heart disease. This is very challenging for us to do something about. So this is increasing in urban areas, and the largest contributor, believe it or not, is internal combustion engines. All right. Here's just also a release basically talking about COVID-19 and how air pollution is linked with the death rates. So we're trying to avoid suppressed immunity, and the environmental factors that we're causing as far as travel, combustion, manufacturing, These things are basically suppressing immunity in both ourselves and in kids, and we have to be aware of that. And the one mitigating factor we have to do something about that is bringing about more fresh air in a building, or again, more fresh air and exercise outside. So some takeaways here, and they partly lead to some of the next things we're going to talk about. Filter level MERV 11, when applied to schools, reduces VOCs, allergens, dust, and reduced PM 2.5, believe it or not. Urban areas near high traffic areas are the last place that you want to exercise or spend time outdoors. So just be aware of that. World average CO2 level is measured in Hawaii, and that's the middle of the Pacific Ocean. So that's the best case scenario. All right, here's really an image of a proprietary indoor air cleaner. You can see all the elements that it has in it to actually clean up air. You know, air and water are a miracle in some ways because they can absorb so many different pollutants and so many different elements, and they naturally cleanse themselves in the water cycle and in the air cycle. Unfortunately, because of persistent man-made pollutants, now we're starting to exhaust some of these systems on a planetary scale. Think about that for a second. That's pretty serious. So why are we coming up with proprietary indoor air cleaners? It's not just what's inside the building, but it's what's outside the building as well. So why is this technology not included already in HVAC systems for commercial buildings, municipalities, and schools? Well, mainly because one reason is this is very new. We're really recognizing how much stuff is in the air that we really don't want to breathe. And we can do something about it. And commercial enterprises seem to be the fast in research and response. We don't know that all these are just the right things to do, but they are very effective, and they also catch the consumer's eye, and people buy these. So the HVAC systems that we're applying, you know, ASHRAE wants good empirical data. They want weigh in from government and medical organizations as well before they're willing to go and recommend all this technology, okay? So the one nice thing is MERV 11 does a tremendous amount. So go ahead and go to the next slide. Here's basically a room cleaner. This is an electrostatic room cleaner designed for commercial buildings. This is actually in a unit I inspected last week, and I took the picture just to show everybody that, you know, it's an effective tool if it's kept clean. But obviously this was installed and the owner didn't even know this existed. It's been in there for 8 years. So not only is it not effective anymore, but it's now contributing to indoor air pollution because it can now host a number of organisms to survive or propagate, whether it's bacteria or viral or something else, or mold spores, but they have a place to live now. Next slide. So MERV 11, like I said, we have MERV 8 on the scale of the very light green on the left here. And we can see that at 0.3 to 0.1 or 1.0 microns, it's about 20% effective of removing those particles. So we move down to MERV 11 and we see it's greater than 20% in that area. In fact, in 1 to 3 microns, it's 65 to 79% effective in removing that. And if we go to 3 to 10 microns, it's 85% or better. So everything on the far right list, everything that's above that, it does and more. So we're looking at pollens, dust mite, carbon fiber, mold spores, hairspray, lead dust, flour, auto fumes. All these things are removed by MERV 11. So they don't go all the way as far as in the spectrum of bacteria and viral removal, but they're the best thing going. And in fact, they do a lot of the previous slide that we see all these indoor air filter technologies, they cover a lot of that just with what they're doing, okay? So there's still things in the air, but these are a tremendous, MERV 11 is a tremendous movement forward. And the reason I talk about MERV 11 is because we received a recommendation this year by ASHRAE of moving to MERV 15 filtration for schools if it's all possible. The challenge is that these physically don't fit in the racks and in the available space of most air handling equipment. But MERV 11 is a good shot that it will fit, or with minor modifications can be put into the units and not reduce the amount of air moving and the amount of dehumidification and cooling to effectively work. Now, one of the challenges we have, I've got a list of kind of what your impacts are on air handlers. When you're moving up filtration to a higher number, you're increasing a pressure drop across that filter, and that means it's more difficult to move the same amount of air. It takes more horsepower. So this is going to be an increased cost in individual filters. It's going to be increased costs in actual energy. It's going to degrade some of the performance of the unit as far as heating and cooling and dehumidification. And it's also going to require possible mechanical changes to the unit. Now, some units will be able to adapt to these without too much problem. The most susceptible unit design is the rooftop unit with the compressors on them. This is DX, or direct expansion cooling, if you don't know that. But they have a more difficult time adapting to these. And it could be much more expensive, require a lot more maintenance. Hot water and chill water systems are going to be much more tolerant to this movement. All right, you can go to the next slide. So we've talked about, next slide, George.
I'm trying.
Oh, okay.
There we go.
It's got a little slow down. So we also have other methods of cleaning air. One is ionization method. So we can do a lot of things. We can like superheat air and sterilize it. We can basically speed up oxidation, and that's what ionization is, of the air, and we can sterilize it that way by creating ozones and excess oxygen molecules that will actually bond to the cell walls of bacteria, mold, spores, and viral cells, and actually kill them. We can use ultraviolet light to do that. So there are methods for killing these things that we use in hospitals and labs. This is just a picture of an ionization lab that I'm assisting a client of mine, and a client really of Greg's and Carl Baxmeyer as well, Deerfield Schools in Illinois. They're actually actively putting these systems in right now. Go to the next slide. So this is what's called bipolar ionization. And basically what it does is it spreads a lot of free ionized air out there in the form of excess oxygen molecules, and they bond to a lot of particles in the air, and they help them flocculate or collect and then catch in mechanical filtration. It also sterilizes the air in what is called a corona, and it actually uses a high voltage discharge to do this. So you don't want to touch the screen element there; it'll zap you. This unit is built for like homes and for individual room units at schools. It retails for about $600. The previous unit is a commercial unit put in the air handlers, and it retails for about $5,000. Ultraviolet spectrum, we've known for a long time through studies that we can sterilize a lot of things by just putting it out in sunlight. And we found out that the shortwave UV or ultraviolet C band is 200 to 280 nanometers wavelength, and it is a germicidal wavelength. It seems to kill a lot of these small single cell organisms, okay? If applied correctly, and if the UV, if we find like UV elements that do actually produce these wavelengths, and we avoid degradation of power supplies, we can put these into air handlers and we can make them work. In fact, hospitals do now, again, laboratories. So this is just an example. It's got a warning sign on it. UVC can be very damaging to the eyes. So these are serviced when they're de-energized, obviously. this couple germicidal bulbs, they call them, or bulbs put in a certain spectrum of light. Again, they are sensitive to accurate power supplies, and the bulbs need to be cleaned. And the application is critical too. What I found for most of these systems is that we have a lot of product distributors who take a one-day class on learning how to put these in. And sometimes there's errors in application. They don't know, they don't correctly read the CFM of the units. They don't integrate them to the automation system. They run, some of them I've seen them run 24 hours, so the bulbs burn out faster than what the recommended rate of usage was. So there's a lot of good product out there, but there's a lot of room for misapplication and poor application. And again, the school district I'm dealing with now, all the parts were shipped, and how they were going to integrate these to the units didn't work at all. They were to turn on from an airflow switch. The airflow switch was missized. None of them would come on when the air was actually moving. So I had to redesign the application to make it solid state and respond to the unit coming on. So keep in mind, this technology is good, but you don't just shotgun this stuff in. You really do need an application engineer, design engineer to help you get the most out of these products. If you don't do that, what can happen is the opposite. Again, the bulbs burn out. Even the ionization systems and the hydrogen peroxide systems, they can actually create pollutants as well if they're not sized right. They can create excess ozones and chemical odors that we don't want. All right. So wrapping up here, some kind of the common practices for schools right now. A lot of school districts, in result of the pandemic, they've really added room air cleaners. These are effective. These could cost, $800 per room. And adding room humidifiers. Some have gone ahead and said, let's add room humidifiers as well. But we're now increasing the noise in the teaching space. And we're also having to service these daily to make sure that the filters are not dirty, that the water is good. A lot of the room humidifiers, they need to be cleaned with bleach or hydrogen peroxide or alcohols on a regular basis so they don't have buildup of any mold or anything like that. Duct cleaning is a very inexpensive way to improve your indoor air quality for air delivery systems that have external insulation. Some have internal insulation. You won't be able to do that. Next slide. Of course, cleaning and disinfecting the internal components of the main air handling equipment, very low cost. But I do want to warn you that if it is very dirty, it's collected a lot of pollutants, and proper protective equipment for staff is very important when we're doing this. Especially if it's recently, I would definitely let a unit set for a week on downtime before cleaning it if I thought it was exposed to viruses. And then improving filtration on the air handler, reduce bypass and leaks is very important. So redoing the filter racks, caulking and sealing them properly, and then moving up from MERV 8 to 9 to 10 to 11 is definitely something that's inexpensive and may not cause harm. Finally, adding electronic air cleaning to reduce bacterial viral transmission. That might actually cost you less than adding all the other appliances like air cleaners in every room. So that is worth investigating, but understand there's a lot of people coming in. There's a lot of noise in the market, and you need help with that research. Next. So my 3 guiding principles really for improved air quality today is chasing energy reduction is the lever that improves the accuracy of your indoor air quality and operating costs. So if you chase your energy, if you set a goal for energy, it's going to make you commission controls, commission equipment, repair faulty outdoor air dampers that aren't working, fix motors, clean air handlers. It's going to help you get, just by chasing how much energy, you're going to calibrate the systems that support that. And that always brings our energy bill down. So that's a very good method of measuring and then managing and getting better indoor air quality. Secondly, cleaning return air grills and supply diffusers. I have a best of list of hundreds of photos where I go in and it's supposed to be perfect in that place. And I go look at so many diffusers that have collected, several ounces of stuff, of dust, bacteria, mold that need to be removed. They're just forgotten. And then finally, all air cleaning methods must be accurately designed and connected to the system, including building automation, with careful attention. So it's very important to include these systems. They all have runtimes and hours, and we do have the capability of programming and measuring the bulb life and the ionizer screen life for all these, and using preventative maintenance and work order tools built into the building automation system. So we should do that. If we don't, then we're not going to get the value and lifetime out of these products and expense, and therefore we're compromising again our indoor air quality. There's a few references for you, and then I'm just going to turn it back over to George now.
Okay, well, thank you, Douglas. I really appreciate that. That was a lot of information and some really good information. So Dr. Langdon, as the moderator, it's all yours.
Great. I had a quick question. Great information again, but the UV piece looks interesting to me. And one thing that you said, I believe, and maybe you can clarify this, kind of a two-parter, but the one was that works in tandem with the existing mechanical filtration that we have. They work together. Is that what you said?
Yes. So instead of increasing your filtration rate, adding UV can sterilize a lot of the air and not require you necessarily to move up that ladder in filtration.
So a school that doesn't necessarily have a lot of funding, that might be one of the top bets to be able to go to. Is that the wrong assumption on that, or is that correct?
No, I think that's a correct assumption, because when you're moving up the filtration scale, you are effectively reducing the ability to move air, how much air per hour. And when you're putting in ionization or UV light, something like that, you're not restricting the airflow or changing those characteristics at all.
I see. And the last piece about the UV, aesthetic could kill single cell organisms, so that wouldn't be in the viral area, the viruses, right? They're not a full single cell. So, and you kind of mentioned that before, didn't you? That that's smaller than the micron or the 2 or 3 microns, correct?
No, the ionization and ultraviolet both can kill bacteria, and they can kill germs. What is difficult is the ultraviolet technology is approved or proven, but nobody's really done a study to prove it. It's just empirical. It's like, we know this works, it's just going to go in, but nobody has a independent third-party study saying that it did. Okay?
Yeah, perfect. Very
That's
good. All right. Is there anything that you tell our audience, and just for future audiences watching this on tape or later on, what would be the first thing to do? I know you mentioned even like reduced cost and doing the basic things, filter changes, going that in that respect. Is that the first step we do right now, and then start looking at maybe how to engineer things more easily? And one thing I was really thinking is, who would I call if I wanted to have someone do a site review on this? Would it be the architectural firm and they would help us get to a specialist, or what would be the easiest way to do that? And I'm sure you guys are swamped right now with what's going on with COVID, but in the future as well.
Yeah, I'll say the architect or the architect engineering firm is probably where you want to go, because number one, they're getting a lot of calls. They're also exposed on a regular basis to a lot of the technology through salespeople, what's available. And they're going to lead you to a specialist like myself that's going to tell you where you need to go, because there are a lot of moving pieces for many schools that I get the call and come to, that, it's possible that they've come close to running to failure, their equipment, and they need many things done before they move to that, just to get back to basic air quality.
Right. And that's not all bad either, just to make sure you're doing at least what you're supposed to be doing from the beginning of the design, right? Maybe it was 30, 40 years ago.
Right. And unfortunately or fortunately, you know, there are so many different applied heating, ventilation, and air conditioning systems that it really takes an engineer to get in and find out what is the capability of what you have now. Is this even a solution we can apply?
Right. Well, fortunately, Wightman has, you know, some experts that actually do the air quality and the environmental piece, and I'm sure others do as well. But it's nice to be able to have that go to and actually find out what the next steps are. So we're all asking the same questions right now, I think. But it's been a great discussion. We're kind of going towards the 145 mark, and I kind of wondered. George, what are you thinking about as far as going to breakouts or just continuing on with some questions from anybody who might want them? Ask them maybe through the chat box.
Yeah, we've got Sam and Brandon on the line. If you guys want to unmute your microphones, if you have specific questions for Douglas or anyone here, we'd love to try to answer your questions at this time. Christine, can you maybe unmute their mics?
Yes, George, I've requested to unmute.
Okay, all right.
And thank you.
Well, Douglas, while we're waiting for maybe questions from the audience, I did have another kind of question for you. You know, when we think about buildings and all of the components that make them work, from the electricity, from the mechanical systems, it's like a living organism. It's almost like a human being that if things are not in balance and if things aren't taken care of, that's when we start to have problems. Would you agree with that statement?
Yeah, I think so. And also, we got to remember that, you know, we're evolving here. So in the 80s and before, you know, we really looked at buildings as kind of a static energy consumer. And then in the 90s and early 2000s, we saw that we had the capability with electronics to really make them adaptive. And both the health and the energy issue came in. It was like, well, why don't we, you know, instead of just guessing how many people, why don't we measure how many people are in the space and then give them the fresh air they need, rather than setting it and leaving it the same for 20 years, no matter how many people come and go.
Right. Could you maybe share with the audience how Deerfield Schools came to the conclusion that they wanted to go the route that they did using the technology that's currently being installed?
Yeah, they basically, we went through several steps. One was fresh air validation or verification. So we wanted to come in and make sure that they were meeting fresh air codes. And we had a lot, they went through a design build mechanical upgrade that was not properly, the record keeping was not there. And so I was brought in then to hire the balance contractors and start validating where the fresh air was, where it was going, how was it rated, you know, where was it going to the students and managed. And I had to hire some contractors to make modifications just to get them really consistent with the code. I don't know why they weren't originally, but they said they decided to go, instead of going the architectural route, they kind of went the design build and kind of wandered off into the desert a little bit. So once it just, you know, when you go, you just design build is not for schools. You know, it's for Wendy's. It's not for schools. And so once we were able to validate that, then really the administration felt that they wanted to go to the next level. And they do some of the air handling systems. Some of the schools are a little bit older. And so we began to evaluate products, and the product there you saw in the picture does have 2 independent lab certificates, and it's very difficult to find products that actually have independent testing certificates. One was that it was compliant to UL 2998 on not producing excess ozone that would be an irritant to occupants. And the second one was that it had actual testing of killing the SARS virus or the COVID-19 virus. Now, they do say in the document it's the 2004 version, not the current, because they couldn't get a hold of any to in their lab to actually do the current version.
Okay.
But that's, you know, that's an excellent reference that it does kill viruses. It kills the same type of virus in an independent testing lab. And it, like I said, it's very difficult to find any product on the market that has both those. So that did bring us down the path with that product.
Okay, well, I really appreciate you sharing that research. Sam, did you have a question?
I did. No, I just stepped out when you asked. I don't have one at this time, but thank you.
Okay. I know that Greg wanted to share a vignette with us.
Yeah, can I share my screen?
Yeah, let me stop sharing.
Yeah, I just wanted to share this story really quick. My niece, Jessica, that a lot of you have met, that was on a previous Wednesdays with Wightman. She was a student, a freshman at Indiana University, and she started complaining about headaches. She was having a bad cough. She had some respiratory issues, and initially Indiana University denied that the school indoor air quality had anything to do with it. And then eventually they did go in and check all of the unit ventilators in the dorm rooms. And it turned out that two of the largest dormitories on campus, all of the units, they opened them up, were completely loaded with mold. An issue where they had not opened them, cleaned them, replaced filters on them for years. And it's an easy thing to overlook. So even some fairly big, sophisticated, educational institutions, Indiana University Bloomington has a big facilities department, particularly clean and maintain. They have a regular schedule for getting their buildings ready for the new school year, and no one had looked in the dormitories in those units. And so it was pretty much every single dorm room had unhealthy levels of mold, and they had to go through very significant cleaning, replacement of all the units. And then some students did end up filing a class action against the university because of the indoor air quality problems. And it wasn't an issue until a few students started to complain. And it was the kind of thing nobody noticed or said anything about until it was a serious problem. So it's the kind of thing that can really sneak up on you. And even an organization like Indiana University can have a significant miss like that in maintaining their mechanical systems.
Well, Greg, thank you for sharing that. And I'm glad that your niece is doing well. I did communicate with her just recently in an email, and she seems like she's doing well. And
yeah, she's doing great now, but she definitely wanted to get out of the dormitories.
Don't blame her. Okay, if no one else has any more questions, I'd go ahead. I just want to make sure that we are cognizant of everyone's time. I was going to go ahead and wrap this up. So, that's a great example where, you're going to get probably more than 101% cognitive improvement, in the dorm rooms, as you had mentioned earlier, Douglas, with one of the other studies from Harvard. So I just want to thank you, Douglas, for being on. Very informative, and there is hope out there that there are products that schools could adapt their facilities and their systems to help improve their indoor air quality at not a totally outrageous cost, like oftentimes we think it is, and just some really good maintenance programs and keeping an eye on that living and breathing organism called the building will definitely improve the indoor air quality for everyone, from students to staff to administrators and community members that come to visit. So with that, I'd like to just thank you one last time. And I want to thank our guests for being on. And the next Wednesdays with Wightman is on January the 20th, I believe, which is Inauguration Day. And we'll be talking about Michigan contract law at that point. So thanks, everyone. Appreciate it. And we will be posting this in our newsletter, and there will be a link to this video for you to be able to watch later. Thank you.
Thank you.
Bye, everyone.
Thank you.
Take
Thank you.
care.